this next part, we will be working on the front end. This will be our Revit addin. So for this, we need a Windows machine with Visual Studio and Revit and the .NET framework installed. Once we have that, we're ready to jump right in. So I'll be using a remote machine with AnyDesk for this. Sorry about that. It might be a little weird to see the window inside the other window, but it's what I have to connect to my Windows machine. So first of all, I'll be opening with Visual Studio. And once we're here, we're going to create a new project, and we're going to use class library for .NET framework. So again, we're going to name it SolidWorks. Again, I'm going to save it in the default folder for repos. And I'm gonna leave everything else as it is. We're gonna choose .NET Framework 4.8 for this. Click on Create. So once we're here, we're gonna have solution with a class library project inside. So we're gonna be doing many modifications to this so that we get all our boilerplate in place to have our addin running inside Revit, building and running and successfully copying all the files we need for our tool to show up in Revit. So now that we're here, we're not going to use our class library to get to host our code. So I'm going to walk through the usual addin setup we use at Evers. We have blog posts about this, and we usually do this automatically, but I think for the purposes of the tutorial, it would be good to cover this here. I'm going to try to do it as fast as possible. So first of all, we start with the default class library here. And what we're going to do is add a new project to our solution, and it will be a shared project. Shared project is what we need. So we're going to name this one common. This shared project will have all our code, and we will have class libraries for each Revit version. So what we're going to do with this is rename this to Revit 2022. For the example, we're going to support two versions of Revit, 2022 and 2024, because those are the Revit versions that I have here, but we could add any Revit version we wanted. So I'm going to move this class to the common project because we're not going to have any code at all in our class library. And I'm going to delete this. I'm going to add another class library. Again, using this same class library targeting .NET framework. And this is going to be Revit 2024. And this strategy might be useful for future support for 2025, which targets .NET Core. So we will cover that in a separate occasion. So again, I'm going to delete this class from here. And here in our references is where we will start adding our shared project. So add reference and shared projects, and we're going to reference common. So this means that this class library will compile the code in common. And we're going to do the same for 2024. So now that we have our shared project referenced in our two class libraries, these two class libraries will start compiling our code. So this looks good. I'm not gonna do much more for now here, but now we're gonna start referencing the Revit API. And for that, we're gonna use Nugget packages because that makes it easier for future support and for other people to work in the project, because they can just clone the repo, if this was a repo, and just install all the dependencies from Nugget automatically and just start working on the project right away. So we're gonna look for the Revit API, and here there are several versions, and we're gonna use this one. Looks good. And for 2022, we're gonna install 2022. So this means we're gonna reference the Revit API 2022 version in our 2022 project, so that each project compiles our code targeting different Revit API versions. I'm gonna click install here. We're gonna wait for that to finish. Move this over here. Done. So now for 2024, we're gonna install that one. And as you can see here in our references, we have Revit API and Revit API UI. So that is gonna allow us to use different classes, methods, and objects from the Revit API. I'm gonna save all here, and I'm gonna go back to my common project, and we're gonna start with the boilerplate that we need to run our addin. I'm gonna make this as simple as possible so that we have the minimal components that we need to run an addin in Revit. So now that we're here, I renamed the file to startup because we're gonna write a class that is gonna take care of registering our application with Revit when the application starts. And it will also create a ribbon tab and a button for us to run our assistant inside Revit. We usually do all the project boilerplate for add-ins with an add-in generator that we have at Everse. We're gonna publish that, so stay tuned for it. It's a console app where you just, with a couple inputs, you just tell it what your project name is, and it takes care of setting this whole thing up with the class libraries, the shared project, installers, CI/CD pipelines, post-build events, and everything else. So stay tuned for that. But for the tutorial, I'm going to show the process from scratch, but without adding any installer or CI/CD or anything too complex. We're just going to do the minimal stuff for this to run in Revit. So let's jump right in. I renamed this file, and I'm going to rename the class to startup. You can do this with Ctrl R and it will rename the file, but it sometimes fails for me in Visual Studio, so I just did that manually. I am going to rename the namespace to common. so that it matches our shared project root. And here, what we're gonna do is implement an interface that is called the external application. This is from the Revit API, so it will add this using statement here. And we can do this because we are referencing the Revit API in these two class libraries that are importing our shared project here, so we can use any methods and classes from or interfaces from the Revit API. So what we have to implement here is a public method that will return a result that is also from Revit API, and we're going to name it on startup. So this will take care of some startup actions for our add-in. And we're gonna pass in a UI control application that we're gonna name application. And inside our method, we're gonna write a try catch block. This will try to register our add-in. So what we're gonna do here is separate another method to create the ribbon tab. So we're gonna say create add-in tab. Now we're gonna pass in the application right here. And then we're gonna return a result, succeeded. This tells Revit that we successfully performed this action that we're doing here. And we're gonna catch any exceptions with showing a task dialog. Saying Zoidberg startup error and just displaying the exception message here. And we're gonna return our result failed right there. So now we need to write our method to create the add-in tab. So we're gonna do that right here. It's gonna be a private void, create add-in tab, and it will receive a UI controlled application. And the first thing we need to do is create the tab. Then we are going to create the panel, and then we're gonna add the button to the panel. It's gonna be just a plain button with no icon, no nothing. I will share the code for that in the repo once again. So here we're gonna call application, create ribbon tab, and we're gonna give it a name, which will be Zoidberg AI. After that, we're gonna proceed to create the ribbon panel. Create ribbon panel, and again, we're gonna call this AI Assistant. And now we're gonna create the push button data. We're gonna call this variable PBD, and it will be a new push button data, which will get a couple of parameters, as you can see here: a name, text, assembly name, class name. So name will be BIM Assistant. Our text will be run the AI BIM Assistant. For the assembly name, we are gonna leave that blank for now. We're gonna jump right into that part later. And our class name will be the method that implements the external command. So we haven't written that yet, but we're gonna point to the path in the namespace that is gonna have that method. So it will be common following our common namespace here, but it won't be on the root. We're gonna separate it into a commands namespace, and our class name will be run Zoidberg. So for the assembly name here, I'm gonna look for that in the executing assembly path, and we're gonna instance an assembly here. Why is this not being found? There, we need a system reflection using statement. So assembly will be exactly that. And then we're gonna use the assembly path, and it's gonna be the assembly location here. And we're gonna pass that right here. So now we have our push button data fully ready. So now we'll proceed to add our button to our panel. So we're gonna need to access the panel as a variable. I'm gonna add that ribbon panel called panel will be the result of that method, and we're gonna create the push button now. Name it PB, and we're gonna say panel add item, and it will be our push button data as push button. We're gonna cast it to a push button, and we're gonna set a tooltip for it saying run the AI BIM Assistant. That's going to be our tooltip, and we're not gonna add an image for now, just to keep things simple. And actually here I forgot to pass in the tab name to the ribbon panel so that the panel gets added to the tab. Sorry if this is a bit confusing. It can be a bit confusing. So Zoidberg AI is our tab name, and our panel name will be AI Assistant, so that we get the AI Assistant related stuff in a panel that will contain our main button here to run Zoidberg. And this is complaining that we aren't implementing an on shutdown method. So we're going to do that so that the interface works. This is the same as our own startup method, but here we are not gonna do anything. So we're just gonna return a result succeeded. And yeah, we should be good. I don't know why it's not refreshing. Let me rebuild. Let me see what this error is. Yeah, I have a typo here. There we go. So now it should compile. Beautiful, it's compiling. So now that we have our startup class here and that everything is compiling, we successfully implemented the external application interface. We can proceed to write our code for our external command that we will be calling with our push button. So inside our common project, I'm gonna make a commands folder, and here we're gonna add a class, and it's gonna be called run Zoidberg. And class, we're gonna go with run Zoidberg, and I don't know, oh, there we go. This is what I need. So I'm gonna switch this to public for now. And as you can see, our namespace here is common commands, and the path of the class will be common commands run Zoidberg. So that matches our button here. So it will be able to call our external command from the Revit UI. What we need to do next is to implement this in a way for Revit to be able to notice this as an external command. So that for that we need to implement an interface here, which is external command. Sorry about that. We have our using statement added automatically, and our external command needs to have an execute method. That's what it's telling us here. So for that, we're gonna implement an execute method, which will return a result enum, same as our startup class. There we go. So by default, this passes in an external command data, and like this is the three parameters that our execute command needs to be able to comply with the Revit API interface. We're not going to be using all of them, but we're going to be using some of that. So again, we're going to wrap this up in a try catch method, and the only thing that we're gonna do here in the future is start the Zoidberg UI that we're gonna build. It's gonna be a simple window. But for now, we're gonna just show a dialog message just for us to build this add-in and have the button in the UI and make sure that everything's running up to this point. And then we can continue with the other stuff that we're going to be building, the actual window and functionality for our AI assistant. So this is going to be a test, and it looks like this worked. Hopefully it will work. Sorry about that. And here, again, we're going to return our result succeeded. Here we're gonna catch any exceptions that might happen. Sorry about that, my keyboard is a little bit buggy with AnyDesk. There we go. So we're gonna copy this line here. So it looks like this didn't work, and we're gonna return a result failed for Revit to know that our command already ran and it failed. So actually, it's good here to pass the actual exception that we're getting. And I did that string interpolation wrong. Now it should work. So we're passing the exception message too. With this, we are gonna try to build this in a way that can run in Revit. We need to add this transaction flag here, and we should be good to go. Now we need to create some other helper files for this to be a bundle that complies with the Autodesk format for Revit add-ins. So we are gonna add here an XML file called package contents. We're gonna dive into this in a second. And the other file we need is a .addin file. So that would be Zoidberg AI.addin. That is like a special file that Revit uses to load up add-ins. So now that we have all our base files, let's continue to implement them. So for our add-in file, this is a manifest that tells Revit some basic information about our add-in application. I'm gonna go ahead and copy that from the repo because I'm lazy like that. Sorry, I didn't copy that apparently. There we go. So as you can see, this has a few properties, a name, the class name for our startup class, which is common.startup. If we go here, we will see common.startup is the path to our base class. Our add-in name will be Zoidberg AI add-in, and the assembly name, this is very important. This will be the name of our DLL. And if we take a look at the build, every time we build our solution, you will see that our DLL name is not exactly matching that in every case. For 2022 is Zoidberg hyphen add-in, and for 2024 it's just Revit.2024. So to fix that, we're gonna go to our class libraries here, and as you can see here, we can set up our assembly name. So this is gonna be Zoidberg.addin. Of course, this will be a DLL format when it's built, and our default namespace is common. We're not going to use that anyways, but just to make things clean, and common. Awesome. So now we're going to go ahead and clean our solution, and we're going to rebuild it. And now our two DLLs are getting built and thrown in our debug bin/debug folder, and it's looking great. It's matching what our add-in file says here. It's a cleaner name. So now our package contents. Our package contents file is a bit longer, and basically it will tell Revit which version of Revit will need which DLL. So we can, set different assemblies for different Revit versions. I'm gonna copy that from the repo as well. So here we have a couple of basic parameters. We have the path to our add-in file, which is the name of our add-in file. Gonna change the description here because it looks ugly, and yeah, the rest looks good. Where in my case, I'm writing evers in our company details. And here we can see that our runtime requirements are minimum 2020, maximum 2024. Actually, this will be 22 in this case. And we can actually get rid of this. You can actually leave this. It won't hurt. It's just that if you want to make it cleaner, we can get rid of this and just leave the Revit versions that we will support in this add-in. So our app name here, we can see that 2022 here, minimum and maximum 2022 is gonna be pointing to a path with our add-in file and manifest for that specific year. And the same for 2024. We'll go into this path in a minute when we build the bundle format for this add-in. So to build our bundle, we're not gonna do that manually. We're gonna set our project app for every time we rebuild this, we want to have a bundle created in the corresponding folder with all the contents that it needs to run in Revit so that we can rebuild and automatically have everything set up. So for that, we're gonna use post-build events. We can access that in the project properties, build events, and here we have two command lines, pre-build and post-build. Pre-build, everything here will run whenever we build this project. Anything there will run before actually building. Post-builds will run immediately after building the project. So we're going to use post-builds because we need to have Visual Studio compile our DLL, and then we're going to copy it to application plugins, which is one of the folders that Revit scans when starting up to look for add-ins. So in this window here, I'm gonna once again copy from the repo our basic post build, but we're gonna clean it up a bit. So basically we're checking that if our configuration name is debug, it will create the necessary directories. This is because we just want to do this when we are debugging our application. This means building and constantly testing it. Once that we are ready for production, we don't want to do this because we would be building an installer and a release and a set of other things that will take care of this when we distribute the application to the users through an installer. But right now, we're gonna just use debug mode because we'll be building this locally. Again, there will be code for installer, releases, all that stuff in the repo. And we have blog posts about that too, if you want to check those out. Okay, so going back to this, we are gonna be creating our bundle folder. This is a format that Autodesk uses, especially if you want to submit your add-ins to the Autodesk App Store, you need to use the bundle format. So this means you will have a bundle folder inside Autodesk application plugins, inside the user's app data folder. Inside that, you will have a contents folder, and inside the contents folder, we will be creating one folder for each version year. So here, the images part, we won't need that because we said we're not gonna add an icon for now. Here, we're gonna be copying our package contents from our solution directory /common to the root bundle folder. Remember, that's the manifest that we created that tells Revit, hey, for this Revit version, use this DLL. For this other one, use that other one. So everything in our debug folder, in our bin debug, so this will be anything that is an output of our builds, will be copied to contents/2022. This means our DLL that we just saw here. Sorry about that. Let me get rid of this for a second. I want to show you what I'm talking about. This DLL being debug Zoidberg addin DLL will be copied to our contents folder, contents/version. Then we mentioned no images. This, we're gonna go into that in a bit. So we should be good to go. Almost good to go. We're gonna do one more thing. In our addin file, we're gonna say copy always because we want this copied to the output directory. So now that we're ready, I'm gonna try building this, and it looks like our post build is failing, and it's trying to copy our debug output to application plugins. So it should be, I'm gonna show you how to enter this folder. So if you do the percentage symbol shortcut like this, it's gonna take you right into our app data/roaming folder inside your current user. Inside there, we go to Autodesk, application plugins, and as you can see, our bundle folder is being created with our package contents inside, but here it looks like it's empty, so not copying our build outputs. And checking that error, it looks like the path we're using could be wrong here. Yep, so it's repos Zoidberg addin/Zoidberg addin, because remember when we initially created the project, it was called like this. In this case, like the first project we had, we renamed it instead of creating a new one, so it has the old folder name. As you can see, we have Revit 2024. On our Revit 2022 project, is the folder has the old name. So to prevent this kind of thing from happening, and actually the build outputs look good, except for a few dependencies that we're going to clean up in a few. To prevent this, we can do, instead of using solution dir here, which resolves to our solution folder, we're going to do project dir. So this is going to jump directly to the project folder and then bin and debug. Let's try that. See if it works. Perfect, it worked. So let's go back to our bundle. Again, application plugins, Zoidberg AI bundle. So package contents, and inside contents, we have 2022, and we have our DLL output. So let's try to open Revit 2022 and see what happens. In the meantime, I'm gonna take a look at something here. Yeah, it looks like it's pointing to the right stuff. So we'll see what happens. I open Revit here. In this case, 2022. And we're going to see if our add-in pops up. This usually fails the first time, but we're going to see. So we're going to wait for this to finish. Well, as expected, this failed. So it looks like at least it's trying to register and initialize the add-in. So that's a good thing. But it's saying failed to initialize the add-in because the assembly does not exist. So probably a mismatch in how we named our assembly. Let's see. So there you go. It's looking for Zoidberg AI.addin.dll, and we have Zoidberg.addin. So we can either rename our assembly, or we can look for the right assembly in our manifest. I think I'm going to go for the second option. Let's close Revit and let's go back to our addin file, our manifest. So as we're going to see here, the name doesn't match. So that should work. Remember, our package contents is pointing to our addin file, and our addin file is pointing to our assembly and the startup class name. So we're gonna clean this up. Actually, I'm gonna go to the bundle folder and delete it and rebuild everything. So we can see this being created in real time, and we have our contents and our add-in file and our assembly. So let's open Revit again and see what happens. There you go. So it's saying it could not be verified because we haven't signed this DLL. We have blog posts about that too. We're not going to cover signing here, but we definitely have covered that before. We're going to choose always load and we'll see what happens. Our add-in should appear here once Revit startup finalizes, and we should see our Zoidberg tab show up, ideally. I'm gonna open this basic add-in.